Hello, everyone. I guess we can get started now. 5:10. Uh, okay. So, hello, everyone, and welcome to the web scraping workshop. Today, we'll be using and learning about Beautiful Soup, a Python package for a package for Python, and how to use it, and just what web scraping is in general. So, my name is Daniel Bokhari, and I'll be the one hosting the workshop for today. So first thing, what is web scraping? For those of you who might not know, web scraping is essentially the act of extracting data from a website. And this is typically performed using automated tools, so it reduces the time spent on collecting information from a website. Web scraping can also be done manually, but it would take much longer. It would be much harder to actually do. So it's typically done using automated things like bots or Python scripts like we're going to be writing today. And once your data is extracted from the website, you can parse this information and collect specific pieces of things from say, the HTML code you got from the website to find information that is relevant to what you are searching for. So what web scraping is commonly used for is mainly things like industry statistics and insights. So it's used to gather information about competitor prices and just like prices in the market. And they can use this information to analyze trends and change up their strategy or like price out their competitors and stuff like that. It can also be used by just your average consumer to look at the prices of a product across different websites and find the cheapest option that they could purchase from any retailer. And you can also use web scraping to analyze stock prices and things like cryptocurrency prices. You can keep track of them daily or even hourly, and you can use this information to make investment decisions and stuff like that. And finally, you can also use it in academic research. So to collect publicly available data across like many different websites. And one of my economics professors actually told us that he used Python and web scraping in his PhD research. And that's actually how I came to learn about web scraping and wanted to learn more about it from that interaction. So when should web scraping not be used? So there can be legal issues surrounding it. Web scraping is generally considered legal when it's used to find information that is publicly available. So just on a website that you can access without needing to log in or have any sort of special permissions. But it should not be used to collect any sort of personal information, especially if the person did not grant permission to collect this information, or if the person who posted the data did not intend for it to be available publicly, but it just somehow was, or you gain access to it. And you should not use web scraping on websites that request you or like require you to log into them in order to access things. So if there is a job board, let's say that you have to create an account and log in to see the jobs on there, you shouldn't use web scraping on that website because the people who made it are not intending for everyone to be able to access the information on their website. So the rule of thumb is you should always ensure that the website that you want to perform web scraping on is they allow you people to use bots or scrapers on them, and they don't say anywhere in their terms and conditions that don't use any third-party applications or bots to access their data. Otherwise, you could get into trouble if they find out. So now on to Beautiful Soup and what it is. So Beautiful Soup is a Python library that is used for web scraping. It helps in the web scraping process because it provides us useful methods to actually search through the HTML code that we would get back from a website. And what it does is it creates Python objects out of the different elements of the HTML code and allows us to search through these elements and find things that we might want to look at. So there is also another library or package called Selenium, which can also be used for web scraping. So Selenium is actually multiple different open source projects, and the Selenium API can actually be used to control a browser. It is far more complex than Beautiful Soup because it can interact with websites dynamically, and it can do things like press buttons on it and fill out fields. Oh, someone's having trouble connecting. Can you see my screen properly? Okay. Then I think it might just be your connection. Okay. So back to this, Selenium is essentially more complex, and what it does, it kind of replicates a browser. So it can pretend to be like a user using a browser, and it can press on things on the websites and interact with the dynamic content on them, which uh, Beautiful Soup cannot, because Beautiful Soup is essentially just accessing the static content of the website, the HTML code. It can't actually do things on the websites like log in for you and stuff like that. Um, so Beautiful Soup is more suited for when you have a simple project to do, like you know that your website will have the data available on it, like within its HTML code, and you don't need to press on anything or go through a set of steps on this website before you can access the data. Um, Selenium would be more useful in general for things like automation and testing. So Selenium can be used to automate a process, like something you do on a daily basis that you don't want to spend time on. You can just write a script to do that for you. And a byproduct of Selenium is that it can also do web scraping just because it has access to the stuff on the website. But Beautiful Soup is better if you just want a simple approach to something and you don't need all the extra stuff that Selenium offers. And also, Beautiful Soup is faster because it doesn't have to load up the whole website like it's JavaScript. It just needs the HTML code from it. So now on to another thing we're going to be using today, which is the Lxml parser. So what a parser is when you get HTML code from a website, it's not in a readable form for Python to use or even Beautiful Soup to use. So it needs to be parsed first and constructed into an object that we can then use in Beautiful Soup and Python to navigate through. And so Python has their own built-in HTML parser called HTML.parser. But today we'll be using LXML, which is external, so it's not built in, because it's much faster at parsing HTML than the one that Python gives you built in. And it's also just more compatible with like many different versions of Python. I believe that the one built into Python is only for 3.2 and higher, versus LXML works for like a bunch more versions. So now I'm going to move on to a live demo because the best way to learn about a new thing is to practice it. So what you'll need to install on your computer would be these three modules here. So you need Beautiful Soup, LXML, and the request library. So to install them in your terminal or command prompt, if you're on Windows, you could run these three commands: pip install Beautiful Soup 4, LXML, and request. And if these don't work for some reason, you could try these alternate commands: pip reinstall and the module name, so Beautiful Soup or LXML. And if that doesn't work either, you could try one of these two. And if none of these seem to work, then you might not even have pip installed on your computer. So you could quickly search up on Google how to install pip for your operating system and do that. So I'll give you guys a couple minutes to install these requirements. And if you want to follow along in coding, you can do so. You can use whatever IDE you prefer, like PyCharm or VS Code. So if someone could just tell me when like they have these things installed, I can move on. Okay, one person's done. I'll just give it a bit more. All right, it seems like more people are done. So, wait, what's wrong with this? Can you see what I'm typing? Okay, it just doesn't show up on my screen for some reason. So for now, we're going to actually work on a sample HTML document instead of moving into like directly into just grabbing stuff from a website. Oops. So can you still see the HTML thing here? All right. So first thing, we want to import Beautiful Soup into our code first. So you just type from VS4 import Beautiful Soup. Oops. And that just like gets Beautiful Soup in so that we can start using it. And I think I spelled it wrong. My bad. Okay. I'll just give you guys a second to write that. All right. And next, what we're going to do, because we're working on a sample file here, we're just going to import this into this code here, or like open it up. So we just type with open the file name, which is sample.html as sample. And we can then create our Beautiful Soup object. So we'll call it soup is a Beautiful Soup thing. And the arguments are we first pass in the file. So we have it open here as sample. So we type it there. And then we give it our parser, which is Lxml. You could also use HTML.parser, but it's slower. So it's up to you. But I'll be using this one. And now what we have created is a Beautiful Soup object that it just grabbed this HTML code here and we can start looking through it. So if you directly print out what you got, print soup, gonna give back just the HTML code exactly as it is here. You could make it look better if you type prettify. It just adds up some tabs so you can look at it better. But now we can use Beautiful Soup to search through our HTML code and find different things that we might be interested in. So if say I wanted to find the title of a website, like within the HTML code, I could do soup.title, which if I run it, would give me back the title tag, which you can see over here in the head, there is the title tag. And if you wanted to just get, say, the text within the title tag, the actual title, you could just add doc text to the end and it grabs it. So you have it here, a title. There's also another thing, dot string. Here it does the same thing, but in reality, there's differences between dot string and dot text. I'll show it a little bit later, but yeah. So you can also grab things like a p tag. So here we have two p tags for which are just like paragraph tags for text that you would see on a website. So if I do soup.p, I can get access to the first p tag it sees within the file, which is I'm a string of text, the first one here. And you can do things like get the text from within it. So dot text, I'm a string of text, you got that. You can also access other things about this tag. So if I wanted its ID, I could access it like kind of like a Python dictionary. Its ID, which is my ID, and you can see over here in the code that this p tag does have that same ID. You can also, this will actually probably be more useful with an a tag. So here we have an a tag which has a href for a link to a website. And if we access the a tag here, it looks for the first a tag and then it grabs its href like this. And we can see we have the link. So that would be useful if you wanted to, I guess, search deeper into the code or access some other thing. Next, we can do things. I'll show you the body tag first. So if we go soup.body, we can get access to the entire body tag. And if you just want to see, so I want to show you the difference between .text and .string. So if I did .text here, what I would get back is the text within these p tags. So I'm a string, I'm another piece of text. You got all that back. But say you just wanted something just within the body tag. So if the body tag had something like this text over here, and you just wanted this, you didn't want like the sub tags and like whatever strings are inside the sub tag, you would instead use dot string. If I save this, well, you get back none because a body tag shouldn't have any text in there. But this is what you would really want to use if you don't want any sub strings or sub tag strings from your what you're searching for. So you can also grab the contents of a tag. So this gives you back an array of everything within this tag. So this body tag has these p tags, and also it includes new line characters, which would be included at the ends of these p tags. You can then, if you wanted to navigate through some code, so you had the p tag first and you wanted to see what is the parent of this p tag you wanted to move out, you could do dot parent and you move back out from it. So the parent of the p tag is this body tag here. So it would give you back the entire body tag. If I did dot parent again, I should get back the whole HTML. Yeah. So you can move up through that if you were searching for something. You could also grab children of a tag. I spelled that wrong. Which gives you a list iterator, which you'd have to use a for loop to go through. You could also do this if you wanted. What did I mess up? Oh. Yeah, you could iterate through everything. And this could have its uses if you were looking, or like if there was multiple copies of the same thing and you wanted access to all of them, you could iterate through it. Okay, so now let's look at, say you are in the body tag here and you are looking at a p tag. Right now, all we get back is the first p tag. But say you want this next p tag or this next element here, the way you navigate through it is you do dot next sibling maybe. And when you do this, because these are all at the same level, they are count as siblings, so you can just move between them. So dot next sibling here wouldn't return anything because it's going to look at the new line first. If I do this again, you'll see that you get back the next p tag, which is the other ID tag here. And you can also do this with previous sibling as well. So you can move backwards and you can get back all of the next siblings in an array. It gives you back the object here. You could use a for loop to go through it. And now let's move on to the find methods, which are sometimes a bit more useful because you can be more specific. So say I wanted to find just a p tag like we were already doing. You could do soup.findp. It will give you back the very first p tag it can find. But if you want to find every single p tag, you do soup.find all p. And when you do that, you get back an array of just the p tags. And if you want to find multiple things, you could give it an array. So I say, give me back all the p tags and all the a tags. So I get back the p tags here and also the a tag at the end. And with find, you can be like very specific with what you want. So instead of giving me back every single p tag, say I want just back the p tag with the other ID. So I only want the second p tag over here. I can copy the ID over and add another argument. ID is other ID. So now when I do this, instead of finding the very first p tag in the HTML code here, it gives me back the second one, the I'm another string of text. So you can find like specific pieces of information in the HTML code instead of just the first one. And this is more useful because you don't have to do soup.p.next.next, which you would sometimes you wouldn't even know how this is structured, and it would be really difficult to find exactly what you're looking for. So now let's move on to there's also alternate versions. So we were looking at the next sibling thing, but you can also just do soup.find next. So let's say I have an object and I say soup.find p. So found is going to be the first p tag, as we know. But what happens if I want to see the next tag or the next p tag? I could do print found dot find next. And this should find the next p tag in here. And it does, and it gives it back. So you can navigate with that way as well. And finally, you can be like super specific with your p tags. So you could, or with your find these filters here, you could say you want the ID to be this, and you also want your class for your tag to be this. So, and when you type in a class, you have to add an underscore. Otherwise, it confuses it with the Python classes and it won't work properly. So you could specify even a class and be more detailed. Because sometimes in a website, the code for the HTML, they have like, well, IDs can't be duplicate, but say you're looking for a class, different elements could have the same class. So you would want to be more specific which ID you want it to look for. So if I do this here, I should get back. I have to print it first. I should get back the p tag with my class and other ID. And that's pretty much the basics of Beautiful Soup. Now I wanted to move on to an example with actually scraping a website. Oh, I forgot to send this to you guys. My bad. I'll send it to you if you want to also use it in your own editor. Actually, I'll send it afterwards. Hopefully now you guys can copy because I'm going to start the actual price finder demo. So now we're going to be making a web scraping thing. We're going to be scraping a website called Newegg for products. You could like look for the cheapest products, most expensive products, or like anything you want. And hopefully it'll help you guys learn a bit more about using Beautiful Soup for on actual websites. So let me load this up here. Okay. So now you guys should follow along. I'm sorry, I forgot to send the sample HTML for the last example. So again, we want to import Beautiful Soup 4 so that we can actually use it. And also we want to import the request library, which you should have hopefully downloaded. And we'll be using this to actually make a request to a website online and get back its HTML code. There's also other modules you could use to grab HTML code. Like there's one built into Python, but that one is also kind of slow and also a bit more difficult to use. So we'll be using this one here. So first thing you want to do when you are grabbing stuff from a website, you want to actually find the website. So I'm going to open up Chrome here. Hopefully you guys can still see that. Okay. So the first thing you want when you are looking to scrape a website is you want its URL. So I don't want to scrape like the front page of this website. I want to look for specific products. So let's say I'm searching for something like a CPU and I want to define maybe like the cheapest CPU or like the any product. I just want to quickly see what is the cheapest one available on this website. So first thing I want is to just look at how the URLs of this website are structured. So you can see that my search here for a CPU is up here in the URL as the last thing for question mark D is equal to CPU. So I could take note of that. And another thing I want to do is because I'm looking for the cheapest item, one option is I could just go through every single thing available on this website and kind of loop through all of these products and look for it. But that could take like a really long time. So some websites could have something like this built in where you can sort by lowest price. And all I have to do is look at this one here and return this and the information I find here rather than spending time and searching through everything and maybe even like spamming this website and they kick me out or something like that. So here I can see when I hit sort by lowest price, they added another thing to the URL and order is one. So I know that when I want to look for lowest prices, I have to add this on to the end of my URL. Say I wanted to look for something like the best selling product. It would be order is 3. So I could add options within my code for someone using it. They could find like the best selling product, best rated product, and I could quickly return them back what it is and its name and everything about it through web scraping. So let's get this set up first. So the URL, I'm just going to be using this search thing here. So I'll copy the entire thing, paste it into here. And since I want this to be like an interactable app, I'm going to add some inputs. So say product is, ask the user to input the name of the product. So what are you searching for? And I can get them to type in whatever they want. And one thing you might notice if you look through this, if you add multiple words to your search, like mouse pad, it's going to be mouse plus pad, not like a space, because you can't have spaces in URLs. So I have to accommodate for that as well if the user types in 2 words here. So I could say product is the product dot replace any spaces with plus. So it's formatted correctly. And I can add this now into this URL here. I can make this, I can like specify exactly what I want within the string to change this CPU instead to be the variable product. So now I can get the user to search for any product. And also this order thing at the end here, we can even ask the user to specify what they want, like how they want it to be ordered, like what they want to see lowest price or best rated product or something like that. So we could say sort is equal to input. So do they want lowest price, say LS, best selling, BS, or do they want best rated, BR? And then we can get that from them. And the thing is, sort, when we go to the URL, it's not going to be BR, BS, or whatever. It's going to be numbers. So I do need to keep track of that. So lowest price would be 1. So I just have to add some ifs. If sort is lowest price, make it 1. And you could probably write this better, like without these elif, like make the input better, but for now we'll just keep this. So if sort is best selling, change this to sort. Actually, I have to check what that is. So the best selling ones have order equals 3. So I'll change this to 3. And else that would be best rated. So the best rated things have order equals 4. So I'll change sort to 4. And then here, and order equals sort. So now I have a properly formatted URL, and we can actually start web scraping. So what I want to do is grab the HTML code from this. And to do that, we're going to be using the request library to make a GET request to the website. So we do HTML equals request.get, pass in our URL. And what this gets back is a request object, which we can't really use right now. So we want it to be in a text form. So it's just plain HTML text that we can start using. So once you have that, we can create our soup object like we did in this example here. Except this time, instead of a file we have on our computer, we're using HTML we grabbed from a website. So we could say soup is beautiful soup, and it will be HTML, and our parser will be Lxml. And now we can start searching for what we want to find. So we are searching for this product, or like the lowest price, best rated of whatever product the user asked for. So first thing I want to do is look at the structure of the code of this website. So say someone is searching for a CPU and they want to see the lowest price CPU available on newegg.ca. What I want to return to them is this. So I would probably want to give them back the name of this CPU, its price, and maybe even like a link to the CPU so like they can click on it and actually access it and like purchase it, maybe, who knows. So what I want to find mainly is the name of it. So you can use inspect element, which is in Chrome. And when you right click on it, click inspect, you get back what is the HTML structure of this website. You get all the HTML code. And what's nice about this is that you can actually look at specific pieces by hovering over them, or if you click on this arrow here, you can find where different components of the website are within the HTML code and search through it there like that. So right now I just want to find this title over here. And it says over here it's located within this A tag in class title. It's within here. So there's a band tag and you have the title down here. And this is what I really want to access. But first thing, because this code is huge, so there's like a ton of stuff. There's like a bunch of div tags and many things. I'm specifically looking only for a product. So instead of like jumping right to this, first I have to tell Beautiful Soup that I want to find like the product on the page, not something like this stuff on the side or that stuff on the top. So I can start filtering down and making my search smaller by finding where every product is located within this page. So I can, if I keep going down here, I can see, so there's this div tag over here that contains every single product within this page. So first thing I want to do is tell Beautiful Soup that I want to reach this div tag over here. So I could say products is equal to soup.find, and here I can see it's a div tag with a class, this long piece of text here. So I could just copy the entire thing. So find a div tag with a class that's equal to class underscore equals all of this. So what's that gonna, that's gonna find the part of the website that contains all my products. If I print this out and just look at what it gives, CPU lowest price. Oops, what happened? Oh, my bad. I printed out the wrong variable. So CPU lowest price, and it's going to give me back just the entire HTML code for every single product within this. But I can see that the first tag here is the tag I was looking for, item cell, wrap border cells. So I'm in the right place. This variable here contains the HTML code for every single product on the web page. So we've started to narrow down our search, and we can continue. So because all I'm looking for is this first one here, I can start moving down through this. I can see that this div here contains the first product on this page. If I shrink this, I can see that there's actually separate divs for every single product. But the one I'm interested in is this first one here. So looking at it, I can see it has a class item cell, and its ID is item cell 9SI. Like they're all kind of different. So because I'm already over here in my search, I have my products, which leads me here. We can just ask Beautiful Soup to give me back the very first div within this instead of searching for which one has this specific ID. Because like this could change from page to page. We could have different IDs. So your code might work for a search for CPUs with lowest price, but it could like completely break when you ask it to search for something else. So I could just say, let's say the target, which is the product I want, is product dot div. So give me back the very first div tag, which is the product I'm looking at. And now we can start looking for the information we want. So first thing, I open this up. I want to grab this title here. If I look, it's down here, there's an A tag, and there's a div with class item info. And this div contains the title, so I would want to go into that tag first. So let's call it title tag is target dot. So the div tag is item info, target dot find div with class, I believe. Yeah, class item info. Item, I think it was a hyphen. So now this title tag should point right here. And I could check that really if I print it out. Print title tag. So I'll run this, same search. And yes, I have the div tag item info with everything inside it. And what I'm searching for, if I could find it over here, this title, it's AMD Athlon 2 X260. That's what I'm looking for. So because we've narrowed it down all the way here, we can just quickly find exactly what we're looking for. So I can see the title here is contained within this A tag, and it also has an href. If I click on this is the product page. So this A tag contains two things I want. It has the title of the product and also a link. So I can just grab both of them from this A tag. And since this is also the first A tag within this div here, we can just go title and also the link is within this title tag, just the very first A tag. And then now we can find exactly what we're looking for. So the link is in this A tag. It's the href of this A tag. So link is just the title link. And like a Python dictionary, we can just grab the whatever is in href. and that would be the link that we want. And underneath it, so if I look here, the A tag, the way it is, it starts here and ends over here. And the text of this A tag is actually the title, not like something within it. The span is just the word refurbished. And that's not what I want. I just want this. So the title of it, I could just say its title is this tag here, the main tag of the title and link dot text. And the reason why I can use dot text instead of dot string is because there's nothing else in here that could cause any issues with finding out the name of this product. So I can just grab the text just by itself. So now we have two things that we wanted, and the last thing we wanted was the price of this product, which we want to tell the user. So I will just, actually I could just look through here. So the price seems to be located in this div tag for action, item action. If I open this up, there is a unordered list called price, and you have here price was, price current. This is what I want, like the price right now. And in this list tag, I can see you have a strong tag which has the dollar amount, and then a sub tag which has the cent amount. So this is where I want to go down to. So what I can do is first, because it looks like this this list tag here is like very specific, class is price current. There's not going to be like any other list tag within my target over here that also has price current. I don't have to narrow down my search like we were doing before. We can just directly go to it. So I could find my price tag by saying price tag is equal to target dot find, and I remember it was a list tag with this class price current. So class is price current. Okay. So now we would be in here. What we want to grab is the strong tag and this sub tag down here. So we could say price dollar amount is our price tag dot the strong tag, right? The strong tag and the text, because I don't want the tag, like the whole tag. I just want what's written inside of it, which is 29. And I can do the same thing for the cents. So price cents is the price tag dot sub tag and give me back the text. So now hopefully I have the dollar amount and price in cents. And I also have my title of my product and the link to it. And that's pretty much all I wanted to find. And now I can return this to the user and just print it out nicely for them. So let's say print and tell them, here's what you're looking for. Forgot the quotes. And then we just give them out the results. So let me format this, say the name of the product is, what do we call it? Title. Here's the price of it. I'm going to format this as well. So the price we got was kind of weird. It was split into a dollar amount and a cent amount. So I'll just do it like this. Price, dollar, and then after it, price cents. And finally, I want to give them the link to the product so that they can click on it and look at it if they're interested. And so link is this link here, this link. And now hopefully everything went correctly and we searched through it properly. And now this program should work. So when I hit run, it's going to ask me, what am I searching for? I will say a CPU. And same thing as this, I'm looking for the lowest price. And okay, so something went wrong here. It could not find the name, but it did find 29.98, which is what the lowest one costs, and a link to it. So if I click on this, it looks like it gave me the wrong link. I'll have to check that real quick. Strange. But let me fix that price thing first. So, I mean, the name, it might be .string. So I'm searching for a CPU with the lowest price. Oh, I can't find it. Let me look through my notes. Maybe I went into the wrong one here. Item info. I might have gone into the wrong A tag. So title tag is the div with item info. Oh, this is a separate one. Class, item title. Let's just like try directly finding the A tag instead of finding the title tag. So change this to the item title, which is this A tag over here. So I can get directly here instead of going through other things first. And I got to change this around. So title tag A, since we are already in the A tag, all we want to grab is the text of this A tag. So title is just title A tag dot text. And the link, because we also grabbed the href, we can just directly access it from the A tag itself. Title, I'm sorry, tag A href. And I already grabbed my title here. I don't need this. Okay. So I'm searching for CPU, lowest price. Okay, so we got back the whole name this time, and hopefully this link works properly. All right, yeah. So now this should work for basically any single product on that website, not just CPU. So if I type here, give me back a monitor and give me the best rated monitor available. And it says it's this LG monitor for $497, and I can check that over here by searching for a monitor and sorting by best rated. And it is this LG T7UL for $497. Right, yeah. So it works properly, and the user can just click on the link and be able to find the product exactly. And yeah, that's the example. If anyone has any questions, you can just ask. Let me zoom up for all the code. Oops. Actually, I'll just share this code afterwards. But yeah, does anyone have any questions about anything we done? I didn't see any chats. No questions? Do you guys understand? Like, at least, did you understand what was happening? Okay, that's good. So now let me just get back here. And finally, if what you found today was interesting and you want to like learn more about it, use it for other things, make your own projects on it. The places you can learn more about it are mainly like the documentation, which is a pretty good place to look because it describes everything in detail. It lists out like every single function that you can use, every single method, and it gives you like some examples on it. So you can learn a lot through that. You can also watch online tutorials, so like articles or YouTube videos to learn more about web scraping, get some ideas, and use that to maybe build something for yourself that you could use. And yeah, that pretty much concludes my presentation, concludes this workshop. Thank you everyone for attending. Could I show the code? Sure. Let me see if I can make it. Actually, I'll just share this to everyone. Yeah, you're welcome, everyone. Thank you for attending. It's weird, I can't share anything. I guess I'll leave this the code, like we'll share it in the announcements, I guess, with the slides, so you can take a look at it afterwards. You're welcome, everyone. I'll stick around a bit more if anyone has any other questions. But yeah, you're free to go.